circuit and microwave session. So as I think before starting, we should know that in your interview, you will be asked first some math topics. So I think the math topics already are covered. So they'll be asking they will be asking you to choose between two maths topics. So I think you can choose any of the, means you can prepare it beforehand, and then you can go for the, then after the maths topics is over, then they'll go for the technical part. So the technical part, they'll ask, so whoever are there who are having this MTech projects, or means MTech projects, you have done something which will be related to the PhD, means the field you are interested in, then you can focus on the project part. In general also, they will definitely ask what you have done for your project and all, so you should be able to answer some questions from your project. And yeah, so before starting the presentation, I should tell that this is not the syllabus or something. We are just telling you how how to solve the problem, and how the interview pattern will be. Means these topics might be there in the interview, and how you will approach the problem. So yeah, these are the some topics which we have prepared. So yeah, so first will be this semiconductor devices. So in semiconductor devices, you can learn about the basic of semiconductor devices, then N type, P type semiconductor, their functionalities, applications, and role of doping in devices, and if its effect on the functionalities. Then you can learn about diodes, transistors, and their working and applications, and difference between MOSFET and BJT, and that in terms of operation and applications. And they might ask you to draw the pin diagrams and all. And yeah, so whenever the questions will be asked, they will start with like what is MOSFET, or what is a BJT, and from that they will try to go deep dive into it. So it's not like whatever you are seeing here, you just mug them up. You should understand everything what you are learning. So yeah, so recent advancements in these fields. And then how you will evaluate the performance of the semiconductor devices, what are the metrics, or how you will measure. And then challenges faced in the semiconductor fabrication and how to resolve them. Then band gap engineering, in that indirect band gap semiconductor, direct band gap semiconductor, what are they, what are the how, okay, what is the EK diagram, and how you will draw the diagrams, and band bending and all. And emerging applications of diodes, and how they are how do they differ from the traditional applications. So yeah, this is just two figures of this direct band gap semiconductor. So hello. Hello, am I audible?
Yes, you are audible.
Okay, okay. Yeah, so they might start with what is a direct band gap and indirect band gap semiconductors. What are like some examples of both. Then they might ask that why indirect band gap semiconductors cannot be used as sources. Then what we can do to make it a direct band gap semiconductor. Those kind of stuffs, they will start from basics and they might go into it. And this is a band bending diagram of this metal and semiconductor junction. So yeah, this kind of diagrams you should be familiar with. And yeah, then optics and photonics. So in optics and photonics, the basics like reflection, refraction, Snell's law, TIR, Brewster's angle, critical angle, ray theory, normal and oblique incidence, diffraction, then interference. Interference, coherence, so temporal coherence, special coherence, anisotropy. So how anisotropy will if it means what will be the effect of the anisotropy, what is the the E axis and O axis, those kind of stuffs they might ask. And the scattering, different types of scattering, birefringence, Fourier optics, formats principle, nonlinear optics, they can ask like this chi2 chi3 processes. And then four-wave mixing, and stimulated Brillouin scattering, self-phase, cross-phase modulations, Kerr effect, Focal's effect. And so where we are using this, that might be a question, that where you can see this kind of nonlinear optics, the application of the nonlinear optics. And that can be asked for anything, so you should be prepared about everything, whatever you are studying. You should have some applications in mind. And then Stokes, anti-Stokes, Raman scattering, etc. And then basic Maxwell's equation, boundary condition, Poynting vector, physical. And so whenever Maxwell's equations we always think about the only the four equations, but you should be able to tell their physical significance also. So they might ask you just to write, but then they might ask you what it means. So the physical significance of each you should know. Then the concept of dispersion, different types of dispersion like chromatic, material dispersion, waveguide dispersion, different kind of dispersion you should be familiar with, and its effect on the system. So how the pulse broadening and all these things happen, those kind of things you should be familiar with. And how we compensate the dispersion, and what can be done to compensate the dispersion. Then this phase velocity, group velocity, and so this group velocity dispersion, those kind of stuffs can be asked. And they might ask you to derive the group velocity from phase velocity. Yeah. And this is just a refraction and reflection diagrams, just showing Snell's law. And this is just reflection, how both thetas are equal. And this is like how the importance of critical angle is being shown here. So this shows how the TIR works. So this kind of stuffs you should be familiar with. They might ask you to draw or they might not, but you should be means you should not only mark the equations like what is Snell's law and all. You should be able to answer the physical significance. And then in photonics you should know this waveguide concepts, different types of waveguides like ridge waveguide, rectangular waveguide, slab waveguide, slot waveguide. Not very advanced waveguide, but this kind of stuff, so you should know at least some basics of this. And wave equation, and the solution to different wave equation, like what will be the solution for a propagating wave, and what will be the solution for a decaying or a radiating wave. Those kind of things you should be knowing. And how the mode propagates in a waveguide, and the BV plot. So V number significance means the V number tells us if a waveguide is can be used as a single mode waveguide or multi-mode waveguide. So those kind of stuffs you should know. And then polarization concept. So this TEM, transverse electric and transverse magnetic polarization, TEM hybrid, different kinds of modes are there. So you should know this kind of stuff. And then fiber optics. In fiber optics, basics, step index, graded index fiber. Why graded index fiber is being preferred over step index fiber? What are these modes, like this linearly polarized mode, LP01, LP11, all these modes. So this TE01, TM10, LP01, LP11, they might ask you to draw one of these. So you should know that when it is 01, where the zero crossing is happening, where in the x-axis or the y-axis. and the numerical aperture and its physical significance. Numerical aperture, you can learn the equation also and its physical significance also. This is just a pictorial representation of this propagating wave and decaying or radiating wave. So you can see that this NF is the wave guiding field, where you can see that the first one below. Okay, I think yeah. So the first picture, you can see that it is going means it is propagating throughout the NF, NC, and NS. Here the NF, NC, and NS is the NF is the waveguide region, NC is the cladding region, and NS is the substrate region. So here you can see that it is going everywhere. So the second one, you can see that it is decaying on the cladding part, but it is going to the substrate also. In the third, you can see that it is only is happening only in the waveguide region, or that NF region, and NC and NS, those parts, the cladding and substrate part, it is not going. It is radiating. So that's what I was telling when I was talking about this solution of propagating waves and decaying or radiating waves. So they might ask you what will be the equation for this. So you should know that this propagating wave means it should have a sinusoidal equation, a sinusoidal solution, and this decaying means it will have an exponential solution like e to the power minus gamma x, and those kind of things. And so yeah, so these are very nicely mentioned in this integrated photonics book by Pollock. I will tell you the book list at the end. And this is just a TETM mode, so they might not ask this kind of stuff, but you should be familiar with like I mentioned earlier also, TE01, TE11, how to draw draw TE01, TE11, and what is the difference between T and TM. If they can ask you, if they will ask you graphically, you have to demonstrate, then you should be able to do that. Then in optoelectronics, the concept of, like in optoelectronics, we have active and passive devices. So here in active devices, we have different type of light sources like LED, laser. And in laser, we can have so many questions like how the lasing happens, when the lasing will happen, like the population inversion, and different operation of lasers, then the gain saturation, line shape function, pulse broadening, then rate equations, rate equations and amplification, and different types of lasers like this VXL, DFB, distributed feedback laser, then erbium doped fiber laser, then AAC laser. So different kind of laser sources are there, which are used in our day to day, means practically we use them. So you should know some basics of this, not go very deep into it, but you should know some basic operations, at least basic operation of this. And yeah, so this laser operations like mode locking, Q switching lasers, and this 3-4 level lasers, why 2 level lasers doesn't exist, and what is the advantage of 3 level, 4 level lasers, which is having more advantage, and those kind of things you can learn. Then concept of detectors. In detectors, you can learn about photodiodes, like pin diode, avalanche photodiode, and the photoconductors, and this photomultiplier tubes. So some basic operations you can learn. And in detector part, we have this noise, which plays a very vital role. So different what are the different kind of noises that are encountered in the photo detectors, like in pin diode, thermal noise, background noise, and in avalanche photodiode, we have the short noise. So those kind of which noise is dominant in which kind of photo detector. If you can go this deep is fine, otherwise you should at least have some knowledge about it, and the effect of the noise on the system, and how to tackle it while designing. and the responsibility and internal quantum efficiency, external quantum efficiency, and overall efficiency. So if we are putting if we are giving some current as I, and how much output we are getting, so those kind of stuffs, the overall efficiency will tell us that. So how to calculate those kind of overall efficiency. So yeah, those kind of things. And as I told, active devices, you can learn little bit about modulators or MZM, etc. And in passive devices, you can learn about ring resonators and the different kinds of waveguides and Mach-Zehnder interferometer, etc. And like Bragg gratings, Bragg reflectors, and different types of gratings are there. If you are familiar with gratings, then you should go little deep to in the gratings and the recent advances in these fields. If you have done any project in any of these topics, then you should have some knowledge that they might ask you what means what you have done, and what is the application you are expecting, and the recent advances in the field you want to work on, and all those stuffs. And yeah, and the books which you can refer is Optics by Yuzen Hecht, and Fiber Optics by Ghatak, and Integrated Photonics by Polak, and Photonics by Yariv and Ye, and Photonic Devices by J.A. Minglu. Again, these are not any like I want to mention that these are not the syllabus which you have to other to. So you are welcome to learn whatever you find is important. And just that whatever we found, we thought that that will be means which were asked in our interviews, previous interviews, and which are generally asked in different like exams. So we have just put those for your references. So if anyone has any questions, they can ask me.
Yes, ma'am.
Yeah.
Ma'am, actually, I have not gone through subjects like photonics, opto-electronics devices, and the fiber optics type things in my entire
Okay.
BTech curriculum and GATE professor.
Okay.
So,
Okay.
do I have to study these things for interview or?
No. If you are coming after BTech, so they know that you might not have studied this kind of topics. So this is what I mentioned is for those people who have already done at least their project in some optics or photonic based topics, or they have studied in MTech or MSc this kind of topics. So you can do what you can do is you should be prepared with this semiconductor devices, and if you are interested in photonics, so it's better to study the semiconductor devices. And some, if you can study, if you have time, and if you can study little bit of this laser, or if anything particular is there on your mind, you can tell. Otherwise it's perfectly fine. So you just don't have to worry much about these things, because yeah, this they will understand those stuffs. Any other questions?
Hello, ma'am. Am I audible?
Uh, yeah,
Hello.
yeah, 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 tell
Yeah,
me.
yeah, ma'am. I am currently final semester MTech student of optoelectronics and laser technology. So, is
Okay.
it okay if I prepare a semiconductor part and optoelectronic devices part and
Yeah.
laser technology for my interview, ma'am?
No, no. Actually, we can't tell them like in mathematics, they will ask for two topics, right? If you are familiar with transform theory or matrix theory or something, they will ask you to pick two topics from the five. So they will ask from those two topics. But here you can't tell. But they might sometimes they might ask you to give some preferences. But I'm not sure that that will be valid for everyone. because in some interviews they will ask directly, and some interviews they might ask for some preferences also. So better you if you have prepared, then the means they might, but I can't say actually. Yeah, at this point.
Yeah, okay, ma'am. And ma'am, like my final semester project is on LED designing, but my interest are in the field of photonic integrated circuit. So, is
Yeah.
there cross question like you have done your project on that field, then why you are choosing this field?
No. If you have to mention, if they will ask to elaborate on your project part, then you should elaborate on your project part, and then you can, when they will ask, they will definitely ask about what means what topic you want to work on or something. What is your interest, topic of interest? Then you can tell, I want to work on this integrated circuit, photonic integrated circuit, or something like that. And nothing is there that if you have done your project in this topic, then you have to carry forward that one. That thing is not there at all. Any other questions?
Arpita, can you just give us an idea of what kind of questions that you had and how you encountered and what depth they went?
No, actually, I have already covered those stuffs, like this indirect, direct band gap semiconductors and all these things. We have already covered.
Okay. Yeah, no, I was there for all the whole session. It's some specific, just to name that I was asked like this. Just to give us an idea of
Sorry.
what would happen. Some specific question, like some specific. Yeah, you did cover, but
Okay. Yeah, correct. So I'll tell that. So one of my this question was, what is the yeah. So difference between, no. What do you understand by direct band gap and indirect band gap semiconductor? Then they asked me to draw the band diagram, and then it was like, okay, for indirect band gap semiconductor, why photon generation only happens in direct band gap semiconductor, and how can we make this indirect band gap semiconductor to means how photon generation can happen in indirect band gap semiconductor also. Yeah, means it was like one by one, step by step questions were there.
Okay. Thank you.
Yeah.
Hello.
Yeah, one by one, please.
Hello, madam. Actually,
Yeah.
these EDC questions are common for everyone, madam. Like, if I interest to communication and signal processing, and
Okay.
for them also, these EDC and microwave questions are
No.
common.
No. These what we are telling is that is for if you are interested in devices and circuits, and microwaves part even I have not covered. My
Okay.
colleague will cover this the microwave part. So if you are from communication and signal communication engineering part, then that will be completely different. That's what I was telling from the starting, that this is not a syllabus, not for photonics or not for the interviews. These are just the topics which we were given, means which not we were given, actually means we prepared for our interviews. So generally what we will prepare for this photonics or devices interviews. That's what. So for communication it will be different. So yeah.
Okay. Madam, and for working already, I have experience of some 3 years working experience. Whether
Okay.
they ask on based on working experience or BTech. Actually, I forgot my BTech project and all. So whether they ask on BTech project or working experience, they ask.
So this working experience was in this communication field only.
No, madam, it is different. It is on DC-DC converters.
Okay. So if you
Uh,
are interested in this
Actually, in
yeah.
this problem is like in that ECE whatever course research areas they provided, there is no DC-DC IC circuits topics, but I was
Okay.
shortlisted in this category.
Okay.
Then for me, which is better also, if you please suggest me, madam.
Okay, yeah, circuits part actually Isa will cover, so she might be able to answer you better. So if you
Yeah,
can,
so did you apply for electrical department if you are working in power electronics?
Yes, power electronics part, I was not shortlisted in that power electronics. I have chosen three options, man.
Okay,
This electronic systems and this, but I was shortlisted in ECE category.
okay. So actually, what you are telling about the
Uh,
DC-DC converters, no? So there is a
mm,
power electronics group. There are multiple groups in the electrical engineering department who work on the converters and all these things.
okay, okay.
In ECE, we mainly focus on signal processing, communication, photonics,
Mhm.
and then there is analog and RF circuits and systems. So VLSI, but the RF, the analog and RF side of it. So for circuits also, there are only low power applications, application based research that is going on in our department. So converters and all, I'm afraid in EC no one works on that. But if you
Uh,
are interested in working for the communication side of things, so you will have to
okay.
prepare for the mathematical subjects like the probability theory and
Uh,
the linear algebra part. I believe the sessions on these are already covered, right,
yes, man. Yes.
on Monday and Tuesday. Yeah. So if you want to come in the communication side, you'll have to focus on uh, those topics. Yeah.
Okay. Thank you, man.
Yeah, sure. So, if there are no other questions, maybe I can start for the microwave part.
yeah, I think so. Yeah, let's start.
Okay. Arpita, please let me know if my screen is visible, right?
Okay, it's first I have to stop share, right? Yeah, now I think it will.
Okay. I think I cannot write on this. Okay. It's taking some time. Yeah. Is my screen visible?
Yeah, it's visible.
Yes, it is.
Okay. But I guess I'll have to. Yeah. So for microwaves, let's first start with the interview format. So usually the most general interviews are concluded in 30 to 45 minutes. And first you will be asked maths. Does not depend which stream you have applied to. Okay. There will be questions from maths. And for the photonics, microwave circuits area, maths is usually it takes 10 to 12 minutes of questions from maths. Then some 20 minutes you will be asked questions on the technical subject. It will be some 20-25 minutes. And then there will be a short discussion on if you have some pre uh, like some ideas that you want to work on in your PhD or your master's research, or they might discuss your BTech or MTech thesis that you have worked on. So this is the rough breakdown of a typical interview in the photonics, microwaves, and devices area. So Arpita has already covered the for the photonics, optoelectronics, and all these things. I will basically cover the microwave part. Professor Vinoy and Professor Devdeep Sarkar, they will be recruiting this time for the microwaves, and they work mainly uh, in the computational electromagnetics and applied electromagnetics, RF microwave circuits, metamaterials, frequency selective surface, and these things. Okay, so basically, these are the parts: electromagnetics, transmission lines, circuit parameters, RF circuits and devices, and antennas. So all of you must be aware that antennas are sort of obsolete now. A lot of research has been done, and the conventional antenna designs are not that. There is nothing much left in the conventional antenna design, actually. So the uh, emerging topics are computational electromagnetics. Not emerging, it's been there and it is there. So there will be applied electromagnetics. It will be focused on that. So starting with the electromagnetics, you can expect questions like Maxwell's equations. So all the four equations, why only four equations, and the significance of the equations, right? Like from where they are derived. Then there could be questions on boundary conditions. What happens if there is a perfect electric conductor? What happens if there is a magnetic material there? Okay, so how the fields change and all those things. Then so the most important thing in the interview is your approach. How are you going to solve the question that they are giving? And mind it, there won't be questions like MCQ that you have already solved in GATE. You have to write every single step. Like that is a good thing to do, so that they can understand your thought process. That is what the professors are going to focus on to. Okay, and even if you don't know the answer, just try to start with whatever you know and catch the hints. There will be multiple hints that they will throw at you, and they will give you a direction. If you are not able to reach to the answer, they will try to give you a direction. If you are able to catch the direction there, that is the best thing for your interview. So electromagnetics, basically Maxwell equation, boundary conditions, that is fine. Then there are some wave equations. It is a little advanced topic, but if you are from MTech, like it is being taught in BTech as well. But if you have completed your masters, then you are expected to know the advanced topics as well. So wave equations, and what are TEM, TE, and TM waves. Uh, drawing the drawing these waves and all those things are little too advanced, but you should know what is the difference between what are plane waves, what are transverse electromagnetic waves, transverse electric waves, what is the difference between here and here, what are the different sort of modes that could be there, TM00, T00, T01, what is the terminology means, at least that should be clear. Then transmission lines. So transmission lines, all of us know, there could be different types of transmission lines, right? So use cases of the transmission lines there, and how the impedance is calculated, the reflection is calculated. Also some special cases in case of transmission lines, which is a quarter wave line and a half wave line. So quarter wave transformer, right? uh, what is the special case here? You could be asked. So it does not mean, suppose a question is being asked that what do you mean by a quarter wave transformer? Okay, so it does not mean that you have to directly jump onto the answer. You draw a lambda by 4 transmission line, right? And then you write the equations for ZL, and then see what happens there, what is the reflection coefficient there, and then you try to answer. That is the best approach to give the answer, instead of directly jumping on to what the terminology means. Like, you should not answer something like you have just learned it by heart, as we used to do in schools, and this thing. So yeah, transmission line, uh, this is fine. And so yeah, circuit parameters. So circuit parameters, as in, you must have studied some network analysis, and you know the Z matrix, the impedance matrix, the admittance matrix, the scattering matrix, the ABCD matrix. So what are these? What is the need for dealing into Z, Y, S? Like, why are we considering all these sort of matrices? And what is the benefit? Like, at high frequency we don't go for a Z matrix, but we go for a S parameter matrix, the scattering matrix. So what is the edge that we are getting there, right? uh, yeah, also you should know the difference between lumped components and distributed components, because this is the basic essence of microwave, right? So how we distinguish between a circuit, if it is a distinguish between circuits, like if it is lumped or if it is distributed, how it is related with the wavelength, right? Wavelength means what is the frequency that we are working at currently, right? So all these sort of things. And basic definition of a scattering matrix is good. How do you so what the definition should, like, what is S11, what is S21, what is the difference between S21 and S12, what is S22, all these. Like, if there is Sij, how do you define it? What does this what is the meaning of writing something like this? So if you are in masters, you should know all these things. You are expected to know these. Yeah, then we have RF circuits and devices. So circuits and devices, there should be, first is passive, then active. So passive, it could be a filter, antennas, right? Power dividers, couplers, like these. Active, power amplifier, LNA, mixer, these things. So in the circuits and devices, uh, you could be asked, like, if you are from masters, you could be definitely asked about power dividers, couplers, and all these sort of things. And also in analog communication and RF, in BTech also, we are taught about the radio systems, right? So what is there in a homodyne receiver or a heterodyne receiver, especially if you have worked on a radar based project or a system based project. Suppose a radar based project, or if you are involved in a design of a up converter, down converter, or something like this, a design of a RF filter, all these things, you should know about the properties of these. So let's say power amplifier you have designed. So what is the uh, so a basic question could be uh, that I can ask you right now is my signal is getting amplified by 20 dB, right? So I'm giving a certain input, I'm getting an output. So where is this gain actually coming from? So this is actually coming from the DC bias that you give. DC bias because it is an active circuit, right? And then a question could be about LNA. LNA, the full form is low noise amplifier. So, and this is a power amplifier. So both of them are amplifiers. But what is the difference here, right? And why a PA is used in the transmitter chain, right? It is the last stage of a transmitter, whereas LNA is the first stage of a receiver. So why is it like this, right? What is the significance of this low noise amplifier? Things like these could be asked. Again, if you consider, like if you have a master's, you could be asked about radar range equation, how it is dependent on r to the power 4 of the distance uh, there, and other Friss equation. Okay. Some of the parameters could also be asked. Like if you have worked on a on a project that included power amplifier, you could be asked what was the gain there, what was the bandwidth of operation, right? All these questions are very important, which shows that how in depth knowledge you have of your project. Just a second. So coming to antennas, we I don't expect a lot of questions on this, but in case if you have worked on a project that included antennas, you should be familiar with the basic terms, directivity. The units are very important. Why this is I here? Okay, focus on the units. How is it derived? And what are isotropic antennas? How do we define the sorry? How do we define the gain of antennas? The impedance? All these sort of parameters that that are the basic terminologies in case of antennas. No one is going to ask you to derive the magnetic vector potential and then come to the equations for the electric and magnetic field. That is not important. But how much grasp you have over the basic terminologies that is being used, that is more important there. So I believe I have covered all the topics here. Yeah, some very important concepts are with the like you should know some of the important concepts like what is skin depth. So when we study about electromagnetics and electric fields and the boundary conditions, we come across a term, a skin depth, that how far any wave can penetrate a conductor or something, right? And if you have worked with RF systems, then what is a SNR, the signal to noise ratio? How is it defined, right? And if you have worked with systems, there could be questions like uh, the link budget. If you have done a master's, BTech people, don't worry about it. Again, like I mentioned in radios, LNA is considered a very important block, right? So why is it considered a very important block? Then radio systems, again there is an issue of image frequency. So how what is image frequency? How do you eliminate that? and all these things could be asked. From circuits and devices perspective, I'll take an example of a mixer. Okay, so this is a mixer. Everyone should know about it. What does a mixer do? Yeah, if anyone wants to join and like make it interactive, some of you can unmute and answer me the question, and we can proceed with a specific example for the mixer. Someone wants? Cannot see the chat. Okay. I hope I'm not going too fast. Okay, so for a mixer, let's say that there is frequency F1 here and frequency F2 here. So mixer basically does the mixing, which means mixing of the two frequency. F1 means there could be a sine of 2 pi F1t here, and there could be signal with sine of 2 pi F2t here. And here what is expected? So there should be a multiplication in time domain, right? Sine into sine. So the output will be actually F1 plus F2, one component, and the other one will be F1 minus F2, the second component, right? So suppose you are designing an up converter, means uh, you have a 1 megahertz signal and you have a 2 gigahertz signal, right? So after mixing, you can go to 2.1 giga, or you can go to 1.9 giga, right? This is the concept. So the higher frequency is called as RF, this is LO, and this is RF out. Similarly, if you want to design a down converter, this was an up converter. This could be like there is an RF port, there is another RF coming in. This could be at 2 gigahertz, this could be at 2.2 gigahertz, and the output will be 4.2 gigahertz and 200 megahertz, right? So now LO, this is a low frequency output. So this is what we then use a low pass filter, and then we get this signal out. Just some applications based on it. So this is a basic device that you should know about. So I have covered the topics here. Uh, I can refer you some books, but again with the disclaimer that it does not guarantee that the questions will be asked from there only. Uh, One book you can follow is Microwave Engineering by DM Pozar. Uh, Second book, that for basics of electromagnetics, you can follow the Element of Electromagnetics by Professor O. Sadiko. These two are good references, given that not all questions will be asked from it. The interview heavily relies on your aptitude and how well you catch the hints the professor give you. Okay, and be confident and answer things, and write your thoughts on the paper. Don't try to come up with the final answer. And if you want to work specifically on something, tell them about your interest in the field. So yeah, these were some of the tips that I had to give you. So if you have questions, I will be happy to answer them. Yeah, any questions?
Yes, ma'am. Yes, dear.
Yeah.
Yes, sir. Ma'am, how important is the EMFT part and optoelectronics part in the interviews? Actually, I am not
So
good at it, but I am good on semiconductors, communication, and maths
so
part.
so in the department in ECE, the interview will be conducted for signal processing, communication, devices, optoelectronics, photonics, and microwave. So there will be sort of 3 to 4 subgroups for which you are applying for. You should have received a email or a Google form, right? So you must have
Yes, ma'am.
decided something. So have you applied for optoelectronics and microwave?
No, I am not.
Okay, so if you have not opted for that, you won't be you won't be allotted to that panel. Most
I
likely.
think I
Yeah.
Yeah, I have applied for the communication means signal processing, machine learning things, and
Hmm.
RF circuits, analog circuits type. So for analog circuits, do I need means I need to study the I have completed the UMT subject, but actually I have not divided it from last 2 months.
Okay,
And
so
currently I
as
am
I
studying semiconductor EDC portion.
no, what I can see in the form, the areas are communication, signal processing, networks and control communications, again signal processing, machine learning, optoelectronics, and then RF microwave. So uh, yeah, if you have applied for, I don't see any semiconductor devices area. So yeah, if you have applied for
Okay.
communications, you will be interviewed in communications. Yeah.
Okay. Thanks.
Okay. So yeah, there is a session in differential equation. It will be likely on Monday or Tuesday. You will be notified about that.
Ma'am, I want to ask you one thing. Can you suggest any book for antennas which is related to antennas basically?
So you can definitely go through Constantine A. Balanis. Okay, that is the most standard book that is followed. That is also being taught at IISc. Yeah. Can you hear me?
Yeah, yeah. And JD Cross.
Yeah, that's also a good book.
Okay, ma'am.
Yeah. So you can go through both of these. Remember, if you are going to interview in antennas, you should focus on the basic terminology. Your concept should be very rigid there. Okay.
Actually, ma'am, currently I'm working in antenna array sensor, so that's why. Uh, is it enough or any other things?
So you should prepare the basics of electromagnetics as well. Okay. And if you are working in antenna array, then your basics of antenna should be very, very strong. Like all the terminologies that I have used, there were only a handful of it, right? You know better what other terminologies are there. And the work. Are you doing your masters or you're a direct
No,
PhD?
I have done my masters. Yeah, for PhD. I applied for PhD.
Okay, so you should be very good in your MTech thesis subject. Okay,
Yeah.
if you have already worked on antennas, then you should know your part well.
Act- Actually, ma'am, I worked on SIW antennas also. So
Hmm.
from that also they'll ask the question.
Yeah, if you
That
have like, yeah, so if you are, see this, that is what we are telling. that if someone is coming after BTech, you are not supposed to know things into very depth. You are supposed to know the basics, right? But if you are coming after masters, you have already worked on a project, okay? And if you want to pursue that project itself in your PhD or something related to that area, then you should be very very good uh, in your master's thesis and the project that you have done. And also, yeah, this does not mean that you should restrict your interview preparation around antennas only. You should also just brush up the concepts of microwave and electromagnetic.
Okay, ma'am. So, ma'am, mathematics also required for that, or only the project, or like only they will ask the question any specific subject, or mathematics also included in
No,
that?
no, I made this clear in the starting of my presentation.
Actually, I came late, ma'am. So
Okay.
maybe I
No,
missed something.
that's fine. You can go through the recording of the session. But for uh, for all the interviews of optoelectronics and microwave photonics, you will be asked maths questions for 10 to 12 minutes, and for that you must have received a list of 5 6 topics, right? So out of those 5 6 topics, you should give two topics. Whether it is linear algebra or transform theory or probability or whatever it is, two you'll have to opt for two of them, and then you will be asked questions on that. So first 5 10 minutes will be that, then next 10 15 20 minutes will be your technical subject. At the end, 5 6 minutes there will be some discussion about what you want to work on, if you have something in your mind, or about your MTech project or something like that.
Okay, ma'am. Thank you, ma'am.
Yeah. Any other questions?
Ma'am,
Yeah,
ma'am, is it important to let the panel know about the research areas that we want to work on?
So, if you want to work on that particular area that you have in mind, you should definitely tell them. Then, at some point in the interview, they will ask you that if there is something particular in your mind that you want to work during your PhD. If you have something, you tell them. And this is important because no none of no two faculties at ECE department work in the completely same area. Okay, suppose you give topic A, then there will be a professor who is actually working in A, and the other won't be. Like, even in the broad microwave area, okay, uh, two faculties are working on two entirely different things. So it's important to let them know there if you have something specific in mind. If you are coming
Ma'am,
from yeah,
ma'am, if we don't have anything specific in mind, so
that's
then
that's
that's it.
completely that's perfectly fine if you
Okay.
don't have anything particular. Yeah. Okay. Someone else was asking some question.
Yeah, ma'am. Ma'am, I also got an interview call from Science Department as well as Department of Electronic Science Engineering Department. So,
Hmm.
will these departments also follow the same interview procedure, like two mathematics topic, and after that, the area that we choose, like I am from optoelectronics and photonics background. So,
Mhm.
could you give me some insights regarding that?
Okay, so I actually interviewed for both of these departments. So for science as well as DAC. DAC, I was interviewed in microelectronics background, and they did ask me maths there, and maths, and then the technical subjects. In sense, there also they asked me maths, but it was not that heavy as compared to ECE and DAC. So you have to prepare maths at any
Okay, ma'am.
cost.
And ma'am, they can ask like related to the question of fabrication, IC fabrication or CMOS fabrication.
So that you'll have to actually, since this is an easy session, I won't I would refrain from stretching the session in that direction. So
Okay.
yeah.
Yeah, and ma'am, in mathematics topic, if I am choosing a transforms theory, so
Hmm.
will they stick to the basics of signal and system like LTI system and the basics of Fourier transform, Fourier series, or they can also ask from DFT, FFT, or Z transform, those kind of things.
Yeah, so if you have taken transform theory, it means transforms, means Fourier transform, Fourier series, DFT, FFT, everything. Transforms means transform, no signal systems there. They won't ask you about LTI and all these things.
Okay.
Yeah. Any other question?
Yeah, there are two questions here. One is to share the yesterday's session, and another is when the calculus math session will be there.
Okay, so calculus differential equation, there will be a session next week, maybe Monday or Tuesday. I'm not very sure on that. And so yesterday's session recording, is anyone
It
here
should be
who
there.
was there? Yeah, it's showing in the chat.
Yeah,
So someone here outside
yeah.
ISC who is able to access that? Can someone tell? None of you are able to access yesterday's recording. Anyone who actually tried to get the recording for yesterday's session? Okay, so in
Ma'am,
that
actually,
case, yeah, tell me.
actually we received a mail from ECE department with the
Hmm.
sessions conducted on 8th and 9th of May. I think
Okay.
in that mail maybe the session up tomorrow will be uploaded.
Okay, so if you are receiving it from email, then wait for some time. You will get the recording for these sessions as well.
Ma'am, I am come up with a new doubt.
Hmm.
Ma'am, what are the chances for a BTech student to be selected for a PhD? In as you already have the experienced applicants and applicants with completed MTech, and as a
Mhm.
BTech applicant, I am very means I am strong in my basics, but
Hmm.
not know the things in so depth. Even don't know what should be the specialization for me in PhD.
Okay,
So,
so
ma'am,
see,
are the chances less for me to come there and they will select the MTech and experienced persons first?
okay, so I'll tell you, there is no prejudice based on if you are a MTech student or if you are a like if you are coming after MTech or if you are coming after BTech. I myself am a direct PhD, which means I I graduated in 2020 my BTech, and then the same semester I joined as a PhD student. Okay, so there is no prejudice there. It entirely depends upon your interview. Okay, like what questions you have answered, how was your aptitude, how well you have caught the hints. Like the interview is all about if you are given a specific problem or if you have identified a problem to work on, are you like they want to see do you have the potential of understanding the problem and then working forward on it. uh, as mentioned in the application form also, there is no prerequisite research experience required, so there is no bias if you are from BTech or if you are from MTech. Only your performance in the interview is going to, yeah, that is the only factor there.
Okay, thank you.
Yeah. Any other questions? So if there are no other questions, maybe we can close, Arpita.
Yeah, that will be fine. So all the best, people. So better prepare well. Maybe it's a little bit helpful for you. We have not confused you more, and yeah, we were able to answer some questions. Let's conclude.
Yeah,
Yeah,
thank you
some
for your time.
question. Yeah.
Yeah, great. And you already have all the links and recordings you will get, so it will be helpful for you. Prepare well and yeah, just focus a lot on your basics. That's the most important thing. Okay, I'll sign
Thank
off
you.
then. Thanks, Arpita.
Yeah, thank you. Thank you. Yeah.